So now we're going to look at how compounds and molecules are formed. There are two basic types of bonds that connect different elements. The first is called a covalent bond. And if you want to think of this, think of it as two people holding hands and therefore they're connected. That's one decent analogy. They're very important, especially when you get into organic chemistry. That's not what we're going to talk about today, though. We're going to talk about ionic bonds. So ionic bonds form when you have two different elements come together because they're charged. And that charge, like Na having a positive charge and Cl having a negative charge, is basically what sticks them together. So some people would think of it as Na donates its extra electron to chlorine, and that's what holds them together. You could think of it like that. But when NaCl comes together, they don't have any charge. So this ionic bond is held together because of charge. One has a positive, one has a negative. But we would say that they have no net charge together. So when you total their charge, it's equal to 0. So we can predict the charge of main group elements simply by knowing their location on the periodic table. Okay, so there are things like transition metals that can have different charges, and you might have to figure out what those are. And you can do that by looking at the formula. So in this case, for copper chloride, I have copper that's been combined with 2 chlorine. Well, remember how we just said that chlorine have a -1 charge? Well, if chlorine have a -1 charge and there's 2 of them, together those chlorines would have a -2 charge. What that means is that to balance it out to 0, copper has to have a +2 charge. So these you kind of have to figure out by the clues that are given to you. We'll look at another clue in just a minute in its name. There are other types of ions or charged species, so all of these things we're talking about are ions, that require several atoms coming together, and when they all come together, they have a charge. So we refer to this as polyatomic ions. So there's several that I've listed here, and these are the ones that you pretty much do have to memorize. So those of you who are with me, there's a chart of this as well. But there are patterns here, things to look for. So keep in mind that carbonate looks like this, but if we add a hydrogen, we can call that hydrogen carbonate or bicarbonate. And then we have things like cyanide is up here, and then if we put an S in front of it, it's thiocyanate. So those sound a lot alike. There's other patterns too. So if we have SO4 minus 2, that would be sulfate. And subtracting one of those oxygens, so it's SO3, becomes sulfite. We see the same type of pattern happen between chlorate, which is ClO3, and chlorite, that's ClO2. Of course, it's up to you as to how you want to memorize these, but you do kind of need to memorize these at minimum, okay? Let's go over and look at that. When you are looking at the first group, these elements will have a +1 charge. You might ask why that's the case. Well, let's talk about that. So you remember how I said that this group is the of noble gases? Well, they're noble and they're gases because they're the most stable things out there. And in truth, everybody wants to be like these noble gases. Specifically, they want their electrons to be like the noble gases. And I'm going to do something that sort of skips ahead of a lot of stuff. So just bear with me here a second. Hydrogen and the group down here below has 1 electron in its outermost orbital. Just go with me here. That has 1. This group would have 2 electrons. I'm skipping over. This group has 3 electrons. This group has 4 electrons. This group has 5 electrons. The oxygen has 6 electrons. And then the halogens have 7 electrons. That means that the noble gases have 8 electrons. And that is what we call the octet rule, or octet, if you would think of it like that. The octet rule kind of says that that's what everybody else wants. They want to have the number of electrons that noble gases have. So for that reason, halogens want to get 1 more electron. And when they can, they'll steal it from someplace else. And when you gain another electron, because electrons are charged with a -1, that means that halogens have a -1 charge. Okay, so rewind that if you need to hear that again. Since things in the chalcogens, like oxygen, have 6 electrons, they're really close to having the 8 electrons. They just need 2 more to get there. So they take 2 extra electrons and have a -2 charge. Those that are in nitrogen have 5 electrons. They want 3 more, and so they take on a -3 charge. Now, as we move over to the other side, I said that this group had a +1 charge. Well, why is that? Because in order to be like the noble gases, it's easier for them to lose an electron than it is for them to gain 7. So just take me at my word for now that that's sort of what happens. And we'll talk about this more as we move on in the semester. So that means that the alkaline earth metals have a +2 charge because they lose those electrons. And these right here would take on a +3 charge. Most of the time, since they're in the middle, they don't really have a charge, but it could be either positive or negative. Now, when you look at all of these transition metals, they can do things that other things can't do. As a matter of fact, they can have multiple different types of charges, which we'll talk about in just one. Okay. So one thing that I didn't really talk about, but there's an easy way to do is just in making formulas. So let's say that you have Na+1, and you know where this charge came from because you know where it is on the periodic table, and S-2, because you know where that is too on the periodic table. An easy way to figure out what that formula is going to be is a crisscross, and forget about the negative and the positive. So this becomes Na2S. So what I mean is the 2 that's up by the sulfur, you need to bring down to the bottom. I don't put 1 down here because that's assumed to be 1. If you want to write that out the longer way to prove to yourself that this works, realize that 2 of Na that have a +1 charge plus 1 of sulfur that has a -2 charge, that would equal 0. So that's how I know it's a balanced formula, because my overall charge is 0. If you start with copper +3 and oxygen's -2, you do have to know which copper you're starting with though. And you flip-flop, then you end up with Cu2O3. So let's check that again. plus 3 charge, and we have 2 of them. That gives me 6. And then I have a minus 2 charge, and we have 3 of those. So that would give you a total of a 0 charge. Be careful, because when you use polyatomic ions, you have to put parentheses on the outside to say, hey, that whole thing there gets repeated. So if I have something like Ba plus 2 and the nitrate -1 coming together, when I flip-flop those, it becomes BaNO3, and then there's the 2. So make sure those parentheses are there. One more example. If we have Ba that's plus 2 and oxygen that's minus 2, this is an exception to these rules because they're already, when added together, equal to 0. So this would just be BaO. Okay? Okay. So next we have to name a lot of different types of compounds that I just showed you how to make. So every formula has its own naming system. These are things that you've got to repeat to kind of understand what happens where. When you have a simple ionic compound where you have two elements that have come together and they're ionic, you just name the first guy, so sodium, and then you take this and you said that would be the chloride ion. You just take off the word ion, so it becomes sodium chloride. BaF2 would be barium fluoride. So those aren't too bad. Now, when you have something that's a transition metal, remember how I said that it could have multiple different charges? Well, if you're trying to tell somebody everything just by the name, you have to tell people what the charge is in the name, which means that we got to use what we just did in making formulas and figure out how in the world do we figure that out, what the charge is. Well, remember how I said Fe2O5 is really because one thing has one charge and one has the other. Well, let's take those numbers and move them up, just like we moved them down before. That would mean that we would have Fe plus 5 and O minus 2, right? So that's where this 5 is how I got the 5 that's over here, okay? So that's where this 5 came from. Sorry, I just rewrote it in a different color you can't see. In a similar way, that's exactly what I did here with the copper 2 nitrate. So if I take these numbers back up, then it would be Cu plus 2 is with N minus 3. And so when I'm naming this, it would be copper 2 nitride. And I'm telling people the charge when I put this value in there. Again, you only need to do this if you have a transition metal, okay? The same way we can name these simple guys, we can get more complex because we could use polyatomic ions, and this is why you really need to know your polyatomic ions. So you could have something like ammonium sulfide because this is the ammonium ion, and there's sulfide. We could have polyatomic ions with transition metals. That's why you need to know the charges of the polyatomic ions. So this would be iron, and see that 2? That's why. And then this would be nitrate. Be careful. It's why you have to know your charges. Copper 2 sulfate may not look like it has a plus 2 charge, but remember, since SO4 has a minus 2 charge, that means that copper has to have a plus 2 charge. See why you need to know those polyatomic ions and their charges and their names. All of these things are related to each other. Okay, next we can deal with things that are hydrates. So what is a hydrate? A hydrate just basically means that some type of formula is combined with a certain ratio of water. So you'll see that by a little times or star, and then you'll see the number of water that are written in the formula like that. So how we determine or tell people how much water that you have there, you just use the normal prefixes like mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca for 1 through 10. So we would say copper 2 nitrate, and then we say this little extra bit because it's combined with water. Tri, because there's 3 waters, hydrate. Hydrate meaning water. Okay, I know we're getting tired by now. One more big section, and that is dealing well with compounds that are not ionic. There's lots of these, but we're going to go with some basic stuff first. Instead of saying ion names, we're going to use just like each name, but tell people how many that you have there. That same mono, di, tri nomenclature that we just talked about, we're going to use that again, but we're going to put that in front of the element as we need to. So nitrogen dioxide is NO2. You could also have something where you have a prefix for both words. So dinitrogen tetroxide. So that's 4 oxygens and 2 nitrogens. Or you could have something like PCl5, which would be phosphorus pentachloride. More commonly, in this class, you're probably going to see acids. And there's different types of acids, but they go through a basic nomenclature. Simple acids are things like H combined with a halogen. And how we name that is hydro, and then fill in the atom name, ic, second word, acid. Like hydrochloric acid would be HCl. Hydrobromic acid is HBr. This one sounds funny. Hydroiodic acid is HI. Or you could have acids that are combined with polyatomic ions. These have specific names as well, and again, why you need to know your polyatomic ions and their charges. So NO3 is nitrate, but we take off the 8 and leave it with ic acid. So this becomes nitric acid. H2SO4, my apologies, that should read 2, is sulfuric acid. H3PO4 would be phosphoric acid. And H2CO3 is carbonic acid. Now, just to throw another kink in there, you know how we said that SO4 minus 2 is sulfate and SO3 minus 2 is sulfite? Well, when we get to that sulfite, to tell a difference between sulfuric acid and this guy, he's going to get a name of sulfurous acid. So we change that ic to OUS. Same thing with HNO2. This becomes nitrous acid. Okay, I just threw a lot at you. Try these. Make sure you've mastered them. There's a worksheet with these on there in the handouts folder. Thank you and good luck.